Sketch a graph of the following. So let's do the thought process now. Again, one variable being squared, parabola. Two variables being squared, and there's a sum between them. What are we graphing? Ellipses. All right. So in part A, notice the bigger number is underneath the y squared. So what type of ellipse will it be? Vertical. Okay. Notice we are not subtracting anything from the x and the y. So what are h and k? 0, 0. Right. So we're centered at the origin. So we have a vertical ellipse centered at the origin for both parts A and B. So on your test, you're going to see, fill in the blanks. You'll see A, B, C, H, K. Oh, H doesn't equal K. Well, in this case it does, but not always. So we already did these two. These are both 0, 0. Okay. A squared is the larger number, so if A squared equals 25, what does A equal? 5. B squared is the smaller denominator. When it's written like this, B squared equals 9. What does B equal? 3. To find C squared, remember, or to find C, excuse me, C squared equals A squared minus B squared. So that's 25 minus 9 is 16. If C squared equals 16, what does C equal? 4. Will they always be integers? No. We're starting off nice. Okay? So centered at the origin, 0, 0. Since it's vertical, what direction am I going to move in for the vertices? Up and down. How many units? What letter do we use for the distance from the center to the vertices? A. So we're going to move up and down 5 units from the center. So up 5. We have a vertex of 0, 5. Down 5. Go to another vertex at 0, negative 5. I will not require you to put the little prime mark on the V. If you write them both as V, that's fine for our purposes. Co-vertices, how far and what direction? 3, what direction? Left to right. So we have a co-vertex here. Oh, that's supposed to be a 3. There we go. And then right here. So once you have your vertices and your co-vertices, that's enough to get a general idea of the graph. So just try to sketch in your ellipse. Last up, we need our foci. Foci are given by the letter C. Foci are always in the same direction as your vertices. So how far and what direction are our foci? 4 up and down from your center. So we have a focus here. I'm using an open circle because technically the foci are not part of the ellipse. They help you get the ellipse. And 0, negative 4. Okay, let us do part B. I want you to find A, B, C, H, K. Give me an A. 12. So remember, A squared is always the larger denominator for our purposes. Give me a B. Okay. since c squared equals a squared minus b squared, we're going to have 144 minus 16. What is 144 minus 16? 128. Square root of 128 contains perfect square. Does 16 go into it? 32, yes it does. Is 16 the biggest though? Oh, 64 is the biggest. 64 goes into 128 twice. Look at that. So this is square root of 64, square root of 2. So 8 radical 2. So do not leave your answer as square root of 128. Clean that up. What's h? What are we subtracting from x? Nothing. What are we subtracting from y? So we're starting at the origin again. Alright, we're going to have to make a slight modification to our axes here. So, also, horizontal or vertical? Horizontal, bigger number is underneath the x. So from our center, 0, 0, we're going to move left and right 12 units for the vertices. So I'm going to have to add a couple tick marks here. You might not see them on your, okay, you sort of see it projected there. Then we have another 2 over here. Mom by Ed. So those are our vertices. 12, 0. Negative 12, 0. And we'll go up and down how many units for the co-vertices? Good. Once you have your vertices and your co-vertices, oh, you can graph your ellipse. Oh, I didn't make that. I'll make that point bigger. Yes. And now the fun begins. How far and what direction are we going for our foci? Foci are always in the same direction as your vertices. 8 square root of 2 units in what direction? Left and right. All right, here's the deal. If you want to, in your calculator, you can find out the decimal approximation of 8 radical 2. You don't need your calculator because the uncleaned up one was square root of 128. Well, 128 is between what two perfect squares? What two consecutive perfect squares? So 128 is between 11 squared, 121, and 12 squared, 144. So as a decimal, square root of 128 must be between 11 and 12. So if I go 11 spots and then some to the right. So, oh, this is really squishy because I made this point really big. That's okay. There's one focus. Please put the exact coordinates 8 radical 2 comma 0. 11 spots to the left. There's the other focus. Negative 8 radical 2 comma 0.